The previous example considered n equals 2 random variables drawn independently from the uniform distribution and determined the distribution of the two order statistics. Now in this particular example we consider 3 mutually independent uniform 0, 1 random variables, and we want to find the joint probability density function of the first 3 order statistics. So for example, if the raw data would come in, and I'll just use one digit to keep things simple, 0.7, 0.9, and 0.2, that if that's x1, x2, and x3, then those get transformed to the order statistics, which in this case would be 0.2 for x1, 0.7 for the second order statistic, the middle value, and 0.9 for x3 as the largest value. By the way, this middle value here is sometimes called the sample median. In this particular setting, since there are 3 factorial equals 6 possible orderings, of the random variables x1, x2, and x3. So in this particular case, you have seen one of the different orderings, but there are 6 possible different ways. This transformation happens to be a 6-to-1 transformation from 6 different pieces, namely script A1, script A2, all the way up to script A6, all mapping to script B. And if you were to look at the Jacobians for each of these, each of the Jacobians of these 6 different one-to-one transformations, each Jacobian happens to be equal to plus or minus 1, just as it was in the last example. So the joint probability density function of the order statistics x1, x2, and x3 is, and in this case f of x1, x2, and x3 for the indexes x1, x2, and x3, that joint probability density function will be the joint PDF of x1, x2, and x3 alone, which is 1 times 1 times 1, which is 1 because they're mutually independent, times the absolute value of the first Jacobian, which is the absolute value of plus or minus 1, which is 1, and that goes on for the first of the 6, and it also goes on for the second of the 6, the third, the fourth, all the way up to the 6th. So we have 1 times 1 in all cases. So this turns out to be 6 on the support 0 is less than x1 is less than x2 is less than x3 is less than 1. So this is how the previous example generalizes, and at this point you probably got the pattern picked up and you could generalize it to any n. You're always going to have an n factorial right here when you're drawing from the uniform 0, 1 population.